zeros. So on 31, we got this polynomial, fourth degree quartic polynomial. So we need to find a P over Q. So you're supposed to know that 6 is the P factor. So the factors of 6 are 1, 2, 3, and 6, because 1 times 6 is 6, 2 times 3 is 6. And then the Q value is this 1 in front of the x to the fourth. So the factors of Q are just 1. So all of my P over Q's, all the possible rational roots, are going to be positive and negative of all these 4 P's divided by 1. So it's positive negative 1 over 1, positive negative 2 over 1, positive negative 3 over 1, positive negative 6 over 1. Now you're going to get points on this test if you can just do this, and I think it's on the quiz too. All right, so now we're going to use synthetic division to find it. Now there's another way you can do it. Like I could take the number 1 and plug into all these x's. So if I plug the number 1 in here, you get 1 plus 6 is 7, plus 3 is 10, plus 6 is 16, minus 16 is 0. So I know right now 1's going to work, but I want you doing synthetic division because we need to use what's left over to find more zeros. So I got 1, 6, 3, negative 16, 6. And I come down here, and this has to be a 0 or I've got to do it over. So I bring the 1 down. I take the number in the box times underneath and stick it under the next number. And then I add these two together. 6 and 1 equals 7. Then take the number in the box times the number underneath, goes under the next number. 3 plus 7 is 10. Take the number in the box times the number under, put it under the next number, add those two together, I get negative 6. And 1 times negative 6 is negative 6. And you see we get 0. So that means that one of my zeros, I'll just write it over here, is x equals 1. Now I need to find another one. Let's try 1 again. So if you remember, this was x to the 4. So this is x cubed, x squared, x, and negative 6. But if I tried 1 again, if I take 1 plus 7 and get 7 plus 10, is 17 minus 6 is 9. That means I won't get 0, so 1 won't work anymore. So we're going to try negative 1. And I'm still going because this is an x to the third problem. As soon as I get 3 numbers underneath here, that'll be a quadratic, and I can use quadratic formula. So I'm going to try to find another number that works that's going to give me a 0 here. So I bring down the first number. Negative 1 times 1 is negative 1. I get 6. Negative 1 times 6 is negative 6. I get 4. Negative 1 times 4 is negative 4. That's not 0, so that is not going to work. So I've got to try another number. So I'm going to come here and I'm going to try the number 2. Again, maybe none of the rest of these will work. I don't know. If they don't work, we're only going to be finding that one answer. So I take 2 times 1 is 2, and I get 9 here. And I get 2 times 9 is 18, and I get 28 here. And I take 2 times 28, and I get 56. And now there's something that I have not told every class because we didn't see one like this. But if you see that you get all the answers down here are positives, all these answers are positives, there are no numbers greater than 2 that will work. So I do not need to try positive 3 or positive 6. They will not work. And it's got to do with in behavior, which is going up. This tells me, since none of these signs change, that the y value, this point 250 is on the graph, the y values are just going to continue to go up because it's going up forever. So I just got rid of having to try the positives of these. So I'm going to try negatives now. Oh, yeah, I got to erase these. And like I said, it's possible none of the rest of these will work, and I may only be able to get you 1 0. Negative 2 times 1 is negative 2. I add these two together and get 5. Negative 2 times 5 is negative 10. I get 0. So anything times 0 is 0. I get negative 6 here. So I'm going to try the next negative, which will be negative 3. And you just got to keep trying them till you find one that works. If they don't work, this might be the only one we can find on this. Negative 3 times 1 is negative 3, and I get 4. Negative 3 times 4 is negative 12, and I get negative 2. -3 times -2 is 6, and I just found another one that worked. So now I have also x equals -3. So I've got two of them. And the good news is this quadratic is all that's left. So I've got x squared, that 1x squared, because this one was x to the fourth, that's x cubed, this is x squared. They go down one each time. So I need to solve this quadratic. Well, this will not factor because the only factors of 2 are 1 and 2, and there's no way to get 4 out of this. So I'm going to have to use quadratic formula. So a equals 1, that's this number in front, b equals 4, and c equals -2. And the quadratic formula that you are supposed to have memorized is right here. That's the quadratic formula, so I'm going to stick these numbers in where they go here. So I'm going to get the other two x-intercepts are going to be -4 because it's b, b's 4, plus or minus. Then I got to square 4. 4 times 4 is 16, minus 4 times the a times the c, all over 2 times the a, which is 1, that 1. So now I got to multiply -4 times 1 times -2, that's 8. So that gives me 8. So I got -4 plus or minus square root 16 plus 8, because I got two negatives, gives me a positive, all over 2. And then I get x equals -4 plus or minus, and I get the square root of 24 because I get 16 plus 8 is 24. That's over 2. And now I need to break 24 down. So 24 is going to be 4 times 6, which is going to be 2 times 2 times 2 times 3. So I hope you see I got a pair of 2's in there. So I get to take a 2 out of the radical. What stays in is the 2 times 3, so the 6 stays in. Now, if you look at the numbers outside the radical, those are the only ones you can reduce. They are all divisible by 2. So what I'm actually doing here is I'm factoring 2 out of all of the top part. So 2 divided by 2 is a 1. You don't have to put a 1 in front of this. So these 2's reduce. So these are my last two zeros right here. So the other two zeros, well, let's see, we had x equaled 1. Let me go back up there so I can write them all down. I think it was -3. It was -3. We got x equals 1, x equals -3. And then we got these two. You can write them like this and leave the plus minus there, or you are allowed to separate them and you can say -2. Oops, I need the equal sign, sorry. -2 plus radical 6 and -2 minus radical 6. And again, you can check all of these answers on your calculator. Does anybody else have one they want to see? Page 150, number 21. All right, so page 150, number 21. So that one says, write the complex number in standard form. So number 21 says the square root of negative 0.04. So the first thing you should do, I'm not gonna leave this 0 in front because this is the same thing. So the first thing you should notice is you have an I inside there. So you're supposed to take that I outside the radical because you gotta get rid of that negative. Now, what you could do now is you could use your calculator and do the square root of 0.04 and get the answer. But I'm going to do it a different way. I know that this is in the hundredths place. So I know this is 4/100ths as a fraction. So I'm changing this decimal into a fraction. Okay? This way I don't need a calculator. And I know the square root of 4 is 2. And the square root of 100 is 10. So I get 2/10. So what that tells me is if you would have taken your calculator and taken the square root of 0.04, you would have gotten 0.2. and got 0.2i up here because 2/10 is 0.2. Now you can reduce this, so this reduces to 1/5 I. And I will take either answer, decimal or fraction. Okay? Now, just so you know, you don't have to write it. The real part is a 0 out here. But you don't have to put 0 in your answer. Does anybody else have anything? Anything else you want to see off any of these? All right, then I'm going to say we're done. I will be here Monday before school, so if you come up with a question, I'm not going to answer the quiz questions for you. You're going to have to do that on your own. Okay, don't forget to take the quiz at the bottom of the assignment page. But you're going to, oh, we got another one. All right, number 43 on page 162. All right, so I'm going to go do that one. Number 43. All right, so let's go over here to 43. All right, so again, I'm going to do it just like I did this problem in class yesterday, exactly like this. You need to remember that a number and its conjugate are answers when you're talking imaginary. Now, this one's going to be kind of nasty, but it's not too bad. So since I'm doing, and also, do you see the red 43? That means you could have taken a picture of this QR code and watched a video of how to do this, but you don't have to. I'll do it with you right now. So this has 4 solutions. Remember, if I have a number that has imaginary, a complex number, its conjugate is also a solution. So what I'm going to do is I'm going to start and I'm going to go backwards. So x equals 2 is a solution. X equals 2 is a solution, and you have to write it twice because this says there's 2 of them. That's a double. And then x equals 1 plus I, and x equals 1 minus I. Those are all solutions. So we got to set all these equal to 0 so I can get the factors. So I get x minus 2 equals 0, and x minus 2 equals 0. And then over here I got x minus, now you can subtract both these over. Or we can leave it in parentheses like this. Somebody tell me, would you guys go ahead and put both of these as being negative, or would you write it like this? And I'll do it the way you do it. Would you write minus this thing the same, or would you put minus 1 minus I? Somebody tell me so I'll finish it up that way. The way it is now, or distribute the -1 to both 1 and I. What would you do? Write the same or DIS for distribute. First one that writes it, that's how I'm doing it. All right, we're doing distribute. So what that means is we're going to subtract 1 and subtract I over, and that will equal 0. And over here, we're going to subtract 1 and add I over here to get those two. Oops, I don't have an equal sign there. Sorry, that should be a minus, and then that equals 0. So what that tells me is these are my 4 factors. So I have x minus 2 times x minus 2 times x minus 1 minus I times x minus 1 plus I equals 0. Now, I told you in class, you want to FOIL the I stuff because it should get rid of the I's and just give you numbers. Over here, I'm going to rewrite this one because this is x minus 2 squared, and I'm going to do the shortcut on this one. Now, this is going to take a little while because you got to do a lot of multiplying. So I'm going to take x times x, and I'm going to get x squared. Then I'm going to take x times -1 and get negative x. And then I'm going to take x times I and get plus xi. Then I got to take -1 times all 3 of these. So I take -1 times x is negative x. -1 times -1 is +1, and -1 times I is negative I. Now I got to take negative I times all of those. So I'm going to move this over a little. So negative I times x is negative xi. Negative I times -1 is positive I. And negative I times positive I is negative I squared. Okay? So that's a lot of multiplying. Now I'm going to combine like terms over here in these parentheses. So what I'm going to do is look for like terms. Well, there is nothing like x squared up here. So this stays x squared. A negative x and a negative x, and there's no more that just have x's, so that would be negative 2x. This xi and this negative xi cancel out. 1, all right, now remember I squared is negative 1. So a negative negative 1 means this is actually plus 1 here. So 1 plus 1 gives me a plus 2 here. And then this negative I will cancel out with that positive I, and I've combined all my like terms. So see, I got rid of my i's by multiplying those. Now I'm going to do the shortcut of a binomial square here. So the shortcut is square x. Now you can write it like this and FOIL this and get the same answer I'm going to get, but this is a shortcut. You can FOIL x minus 2 and x minus 2, but the shortcut is take the first term and square it. Take the last term, goes to the end and square it, and then take x times negative 2 times 2. Well, x times negative 2 is negative 2x times 2 is negative 4x. Okay, now I'm not done because I've got to multiply this trinomial times this trinomial. So this is going to get long again. So when you have when you got 4 solutions, it takes longer. So I'm going to take x squared times all these. So x squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. X squared times 2 is 2x squared. Then negative 4x times x squared. Now I could write that over here, but I'm going to combine like terms. So what I'm actually going to do is I'm going to put these like terms under these. So negative 4x times x squared is negative 4x cubed. And negative 4x times negative 2 is positive 8x squared. And then negative 4x times 2 is negative 8x. Now this way I got them lined up so my adding will be easier, I hope. Then I got to take 4 times all 3 of these blue ones. So 4 times x squared is 4x squared. And that's a positive, okay? And then we got 4 times negative 2x is negative 8x. And then 4 times 2 is 8. Now I'm going to add up these like terms. So x to the 4th is the only one. Negative 2 and negative 4x cubes give me negative 6x cubes. 2 and 8 give me 10, plus 4 give me 14x squareds. Negative 8 and negative 8 is negative 16x's, and then plus 8 doesn't have any like terms. And that right there is the function. That right there is the function that gives me those 4 zeros up here at the top. So again, that takes a while. And there's a lot of places where you can screw up algebra, so you got to try to be careful. Anybody else got anything they want to see? Okay, so once again, down here at the bottom of my homepage, you guys have a quiz to take today. Or sometime this weekend. You're going to click on this quiz and you can print it off and take it, or you can just look at it on your screen and do the problems and turn in your work. I want to see your work. And that will be due on Monday and Tuesday, the quiz. Anybody else got anything? Oop. Okay, I don't see anything else coming through for questions. I hope this helped you, and I will see you guys on Monday and Tuesday, depending on what day is your day. So have a great day, and have a good weekend. Stay out of trouble. Do what's right, not what's popular, and I'll see you Monday, Tuesday. Bye.